Hey everyone, welcome back for Unit 3 of our geometry course. In Unit 2, we really skipped over just about everything, so if you're looking for Unit 2, all we really did there was some algebra review. So we're going to go over some skills now before we get started that we need to know in order to get going in Unit 3. So first, adjacent angles. We just need to remember what adjacent angles are. They share a common vertex and a common side. So adjacent angles, a couple angles put together like this. Okay, two angles are supplementary. That blank is a little bit small there, but two angles are supplementary if the sum of their measures is 180 degrees. Okay, the midpoint of segment AB is M, so that's going to apply to questions 3 and 4 here. M is the midpoint. Find the length of AB. So in other words, we've got a segment like this, segment AB. Its midpoint is M, and here AM is 5x minus 2, and MB is 2x plus 7. We want to know the length of AM. Since this is a midpoint, I know these are congruent. So 5x minus 2 is equal to 2x plus 7. So I can subtract 2x and add 2, and I'll get 3x equals 9. And when I divide by 3, I get x equals 3. So if I put a 3 here, I have 5 times 3 minus 2. That's 15. Minus 2 is 13. And then 2 times 3 plus 7. Okay, so that's 6 plus 7, which is also 13. And if I add those together, I will get the length of segment AB. The length of segment AB is 26. Okay, same skill here for number 4, but I'm going to do it without a picture this time. I've got 4z plus 1 equals 6z minus 11. So I'm going to subtract 4z, the smaller of the z terms, and I will add 11 and get 12 equals 2z, and divide by 2, so z is 6. Okay, so if I plug in z here, I get 4 times 6, which is 24, plus 1 is 25. Then 6 times 6, which is 36, minus 11 is 25. Okay, so that's good that these came out the same because they're supposed to be congruent segments like up here. Okay, now I'll add them together to get that the length of AB is 50. All right, find the measure of each numbered angle. Okay, so I need the measure of angle 1, the measure of angle 2, the measure of angle 3. Okay, so now these are vertical angles. That means they're congruent. Angle 2 is 38 degrees. These are a linear pair, which means they are supplementary. Okay, so 180 minus 38 will give me angle 1, so 180 minus 38 is 142. Okay, so I get 142 for angle 1, and that will be the same as angle 3. Okay, here I've got a right angle. Straight across from that must be another right angle. Okay, those are vertical angles. And then this linear pair has to add up to 180. 90 and 90 makes 180, so that's a right angle, and that's a right angle. So the measure of angle 1 is 90 degrees. The measure of angle 2 is 90 degrees. The measure of angle 3 is 90 degrees. Then here I've got vertical angles again. So I've got the measure of angle 1 that I don't know yet. The measure of angle 2 is 135 degrees. The measure of angle 3 I don't know yet. 1 and 3 will be the same. So 180 minus 135 is 45. So these are both 45 degrees. Okay, then a diagram. Line QR is perpendicular to line WX. So perpendicular, this is a new word that would have come up in Unit 2, but we didn't talk about it yet, so this is going to be kind of new to you. So perpendicular means that the two lines are going to form a right angle. Okay? Perpendicular also has a symbol. It looks like this. It's like a capital T upside down. Okay, so if two lines are perpendicular, they form a right angle. So I've got my two lines. I'll call this one line QR and this one line WX, and they form right angles. They are perpendicular. Then lines M and N intersect at point P. So I've got line M, line N, and their intersection is point P. Okay, so now we are on to some new terms. Parallel lines are coplanar lines, so they lie in the same plane, that do not intersect. Okay, parallel lines look like this. Okay, they're never going to touch each other, and the way I can use symbols to tell you that these are parallel is an extra set of arrows. Now those are parallel to each other. If I put on one more here, now they're not parallel because they don't have the same number of extra arrows, but now they are parallel again. Okay? Skew lines are non-coplanar lines that do not intersect. Okay, so here is an example of two coplanar lines that do not intersect. They are parallel. When I put them like this, not touching each other, but they're also not in the same plane, they're going different directions, those are skew. Okay, so here's parallel lines, here's skew lines. Parallel planes are planes that do not intersect. Like in this picture, the blue plane and the green plane here are parallel planes. Plane T and plane U will not intersect each other. Okay, so lines M and N are parallel. See the extra arrow there? That says they are parallel to each other. Okay, and here's the way you can symbolize that. Line M is parallel to line N. Lines M and K are skew lines. So line K going this way, line M going this way. They're never going to touch each other, but they're not in the same plane either. Those are called skew lines. Planes T and U are parallel planes, so plane T is parallel to plane U. Lines K and N are intersecting lines, and there is a plane that actually contains both of them. That plane is not shown. Anytime you've got a pair of intersecting lines, there is a plane, this one would be vertical, there is a plane, whether it's shown or not, that will contain any pair of intersecting lines. Think of each segment in the figure as part of a line, which should be easy because a segment is a part of a line. Which lines or planes in the figure appear to fit the description? Okay, lines parallel to CD. So here's line CD. I'm looking for a line or lines parallel to that. So here's one that's parallel. Here's another one. Here's another one. But I also want it to contain point A. So lines that are parallel to CD and contain point A are right here, and that is line AB. Lines skew to CD containing point A. So skew lines to CD, there's one here, 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 and here. But they need to contain point A, so that's right here. Line AH contains point A and is skew to CD. So that's this line right here. Perpendicular to CD and contains point A. That's right here. Forms a right angle and it contains point A, so that is line AD. And then a plane parallel to plane EFG. So plane EFG, so that's this plane right here. A plane parallel to that contains point A. That would be this plane up here. So those are two parallel planes, and this one contains point A, so I could call it plane ABC, or any three letters in this plane. I could call it ACD, BCD, any three letters in that plane. The parallel postulate says if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. Okay, so if I draw a line and a point not on the line, how many lines can I draw through this point that would be parallel to this line? Well, the answer is one. There is one, whether it's drawn or not. This right here is the line through this point that is parallel to this line. The perpendicular postulate is similar. If there's a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So if I draw a line and a point that's not on the line, that means there is one line, and it is right here, that goes through this point and is perpendicular to that original line. In this image, we need to name a pair of parallel lines. I see double arrows here and here. That tells me that those lines are parallel. So line MD is parallel to line FE. So we're just assuming that these go forever, because it does say parallel lines. So we're just assuming that this goes forever. We're considering these rays to be part of lines that continue in both directions. A pair of perpendicular lines. Right here might be kind of difficult to see, but there is a little square right here. So that means that line BF is perpendicular to line MD. Is it even possible that line FE, okay, so that's this line right here, is parallel to line AC? Now, I know they certainly don't look parallel, but is it possible? And the answer is no. And the reason is that this line and this point M, there's already a line through this point M that is parallel to FE. So through point M, line MD is parallel to line FE. And through that one point, point M, there can be only one parallel line to FE. So AC contains point M. It cannot also be parallel. Through point M, I've got one line parallel to this one. through point M, I cannot have another line that's parallel. Okay, now looking way above, name lines through point H that appear skew to line CD. So here's line CD through point H. Are there any lines that appear to be skew to this line? I would say there are two. I would say AH is skew to CD, so line AH. I would say that line EH is also skew to line CD. Okay? In example 2, can you use the perpendicular postulate to show that line AC is not perpendicular to line BF? And the answer is yes, you can use that to show that it is not perpendicular, because through point M, so we're looking at line BF, line MD is already perpendicular. So line MD is perpendicular to line BF. So I can't have another line through point M that is also perpendicular to line BF. I can only have the one. All right, now we're going to talk about different types of angle pairs, starting with a transversal. Okay, so a transversal is a line that intersects two or more coplanar lines. So here's a line, here's another line, here's one line that intersects both of those. That is a transversal. I'm going to call that line T for transversal. Okay, it transverses two or more other lines. Okay, so now based on two lines and a transversal, corresponding angles are angles in corresponding or in similar positions. Okay, so for example, here's two lines and a transversal. Angle 1 and angle 2 are both kind of in a top left position. So those are corresponding angles. Alternate interior angles are angles inside of two lines on opposite sides of the transversal. So here's two lines and a transversal. I'll call this angle 3 and 4. They're both between these two lines, but they're on opposite sides of the transversal. Alternate exterior angles are angles that are outside of two lines on opposite sides of the transversal. So when you see alternate, you should be thinking opposite. So here are two lines and a transversal. Angle 5 and angle 6 are both outside of the two lines, and they are on opposite sides of this transversal. Consecutive interior angles are also called sometimes same side interior angles. They are angles inside of two lines on the same side of the transversal. So here's two lines and a transversal. Angle 7 and angle 8 are on the same side of the transversal inside of the lines. Those are consecutive interior angles. Okay, so name some corresponding angles. So we've got angle 1 and angle 5. They're both in a top left position. In a top right position, we've got 2 and 6. In a bottom left position, 3 and 7. And in a bottom right position, we've got 4 and 8. alternate interior. Now they have to be between these two lines and on opposite sides of the transversal. Alternate interiors are like 2 and 7. Or 4 and 5. Alternate exteriors, now they have to be outside of these two lines, but on opposite sides, like 1 and 8. Or angles 3 and 6. And then consecutive interior, between the lines, but on the same side of the transversal, like angle 2 and angle 5, or angle 4 and angle 7. Okay, classify the numbered pairs of angles. So I've got angle 1 and 5 here. They are both in a top left position. Those are corresponding angles. Angles 2 and 7, those are outside of the lines, but on opposite sides of the transversal, those are alternate exterior angles. 4 and 5 are both between these two lines, but on opposite sides of the transversal, those are alternate interior angles.